The following is the details and objectives of this course. Please read it carefully, and start the course. Gasoline engine combusts air-fuel mixture inside the combustion chamber to generate energy. This energy is converted into mechanical energy to obtain required drive force to move an automobile. In this session, we will learn about the gasoline fuel system, its structure and its characteristics. Depending on the method fuel is injected into the combustion chamber, gasoline engine is categorized into MPI and GDI. In multi-point injection system, the fuel is injected at the intake port, where the air inflows into the combustion chamber. And after the fuel mixes with the air, the mixture flows through the intake valve and into the combustion chamber. But unlike the MPI system, the gasoline direct injection system injects high-pressure fuel directly into the combustion chamber. In this session, we will examine the MPI type gasoline fuel system. We will now learn about the fuel system composition in a gasoline engine. It's the system that supplies fuel required by the engine. It's a highly important component, in which the engine performance and output is based on the air-fuel mixture ratio. Fuel system is composed of a fuel tank, which stores fuel, fuel filter, which removes impurities in fuel, and fuel pump, which supplies fuel to the engine. The fuel transported by the fuel system is supplied into the combustion chamber through the injector. Injected fuel amount and injection timing is computed and controlled by ECU. First, we will learn about the fuel tank. Fuel tank is a container for storing fuel. Its capacity varies depending on the vehicle usage and structure. In the past, fuel tank was made of thin steel plate. But recently, plastic material is used for reduced weight and to prevent rust. In addition, compartment wall called the baffle is installed inside the tank to prevent fuel from sloshing while driving and to increase durability. In addition, rollover valve is installed to prevent secondary accident caused by fuel leakage in case of vehicle rollover. Fuel pump that sends fuel from fuel tank to the engine is electric motor type. It is controlled by ECU, and its discharge pressure is approximately 3.5 bar. In addition, it is installed inside the fuel tank to suppress pump operation noise and prevent vapor lock. Fuel pump is integrated with fuel sender, which measures fuel volume, and fuel filter, which filters impurities in fuel. Fuel sender, which measures the fuel volume inside the fuel tank, uses variable resistance to detect the position of the floater, which changes based on the fuel level. This information. Next, we will learn about the fuel rail. Also known as the delivery pipe, the fuel rail stores the fuel supplied from the fuel pump and distributes the fuel to the injectors. Fuel pulsation may occur inside the fuel. We will now learn about the injector. When electricity flows in the injector, the needle valve in the injector is fully opened, and the fuel is injected into the intake manifold. Constant pressure of fuel is maintained in the injector, and the pressure is proportionally increased based on the electricity flow time in the injector. Accordingly, air-fuel ratio is computed by the engine ECU based on the intake airflow, and injector injection timing is controlled. The ultimate objectives for electronic control gasoline engine is to increase performance and fuel efficiency while reducing emission gas. Precision fuel control is required to achieve this. So the engine ECU controls optimum injection timing and injection volume corresponding to the engine's driving condition. First, we will learn about the injected fuel amount control. Optimum air-to-fuel mixture to achieve full combustion in a gasoline engine is also known as air-fuel ratio. In other words, air-fuel is the ratio for achieving optimum engine performance with minimum emission gas. 14.7 grams of air is required. We will now First, we will learn about the injected fuel amount control. Optimum air-to-fuel mixture to achieve full combustion in a gasoline engine is also known as air-fuel ratio. In other words, air-fuel is the ratio for achieving optimum engine performance with minimum emission gas. 14.7 grams of air is required to fully combust 1 gram of gasoline. So air-to-fuel ratio is 14.7 versus 1. Based on this setting, the air inflow into the engine is measured, and the injected fuel volume is controlled. In addition, various information, including engine, air temperature and driving condition, are computed to engage optimum fuel volume control. Click Tip button to view more detailed information on the method of controlling power output in a gasoline engine. We will now learn about the order of fuel injection and ignition. Finally, we will learn about the fuel injection timing. First, fuel is injected into the intake port in an M. We will now learn about the order of fuel injection and ignition in a gasoline engine. Fuel injection and ignition order varies depending on the arrangement of the cylinder and the number of cylinders. In general, inline 4-cylinder engine has injection and combustion order of 1 3 4 2, 1 2 3 4 5 6 for V6 engine, and 1 2 7 8 4 5 6 3 for V8 engine. The reason for different injection and combustion order based on engine structure and number of cylinders is to minimize engine vibration. So optimum order of combustion in cylinder based on engine crankshaft structure is set. Finally, we will learn about the fuel injection timing. First, fuel is injected into the intake port in an MPI engine. When fuel is injected, it is mixed with intake air and flows into the combustion chamber when the intake valve is opened. Due to the structural limitation, the fuel is injected at the end of the exhaust stroke, at which point the intake valve starts to open. But in a GDI engine, fuel is injected directly into the combustion chamber. Accordingly, fuel is injected at intake stroke and compression stroke to achieve optimum efficiency corresponding to engine driving condition. Please review the lessons you've learned in this session through simple quiz. Now, let's wrap up what we've learned today.